Case 2. That is the case we're still having this system. This is S bar prime, which is A and the vector. Where also to get your eigenvalue, you solve the system. To get your eigenvector, you solve the system. But in this case now, the eigenvalues R is repeated twice and produce one linearly independent eigenvector. What we are saying here is that the system generates eigenvalues, okay, which is repeated twice, okay. R1 is equal to R2, and it now produces just one. These are two values which are the same. Now produce one eigenvector, one linearly independent eigenvector. Then we can find a generalized eigenvector U2 by solving, and the solution associated with it is so this is solution associated with repeated eigenvalues that produce one linearly independent eigenvector. So this is the general solution. Okay, we are going to look at that. So that means the general solution will be equal to C1, this one is functions of G, then plus what? So we can call this one x1, then we can call this one x2. So that is C2 x2 as the functions of T. So that's that on these aspects. So the next thing we want to do now is to look at questions and look at questions. And the question will be based on case 2. Yeah, question 1. We have these questions, solve the system. We have the x bar prime. This is a vector derivative. This is a matrix, and this times this vector. So without wasting time, let's dive into the solution. Step 1. Calculate the eigenvalues. So that's the first thing to do. And to do that without wasting time, don't forget that this one is A, that's matrix A. So calculate the eigenvalues, then we solve this expression that we got you. This is determinants. Then the meaning of this expression is just go back to your matrix A, and then this is your leading diagonal, and that will be your leading diagonal minus R, 18, 2, minus 9, minus R. Just the leading diagonal. Other value remain constant. That's a 3 minus this times minus 9 minus R, and then minus this minus this one times this one. Okay? So that will be plus what? Plus 32. 18 times 2, 18 times 2, that's 36. We got to 0. That's 36. So this one times this one, that's minus 27. This one times this one, that's a minus 3R. This one times this one, that's a plus 9R. And then this one times this one, that's a plus R squared plus 36 equal to 0. So that will be R squared. Then we have minus this plus this, that's a plus 6R. and then minus 27 equal to minus 27 plus 36, that's plus 9 equal to 0. Then we can factorize this. This one, P8, 1 here, 1 here. Factors of 9 is 3 and 3, and that can give you 6. That will be plus 3, plus 3. So we now have R1 is equal to R2, and that's what minus 3. Okay? So with this now, we can go straight to calculate eigenvector. We solve this system. This is the formula. And we substitute here, that will be this is minus 3, that will be plus 3i, and this equal to 0. The meaning of that expression of this one, the meaning of this is to go back to your matrix and begin to add plus 3 to your daily diagonal plus 3. So that will be 6 minus 18, 2, and this will be minus 9 plus 3, that's minus 6. And then this one is your eigenvector. The component of that will be u1 u2 equal to 0, 0. The next step is augmented matrix. Augmented matrix. And that will be 6 minus 18, 2 minus 6, line 0, 0. So that's the augmented matrix. So the target now is to have at least 0, at least a 0 in the row 2. So how do we do that? Then we do our row operation. And that will be equal to row 2 is equal to 3 times row 2. That will be 6 here minus row 1. So I'm going to have row 1 is not changing, it's just a reference point. And this is already times 3, that's 6 minus this, that's 0. This one also, that's minus 18, minus 18. So this is also 0. Then the next thing, row 1 will be 6 G1 minus 18 G2 equal to 0. So 6 G1 equal to 18 G2. So we can divide by 6, we can divide through by 6. So G1 is equal to 3U2. So consider U2 to be x. So the vector, the eigenvector, will be equal to U1 is what? U1 is 3x and U2 is x. So we can take this one outside, then we have what? 3, 1. Okay, so let's take this one as 1. So the eigenvector is 3, 1. Vector 3, 1, 4. R equal to what? Minus 3. So we can have the solution for this eigenvector. Have the solution as 3, 1, and then exponential to power minus 3t. So at this point now, we cannot find another linearly independent eigenvector. So in that case now, we need to solve what? We need to find generalize eigenvector U2 by solving. Okay, and when we say linearly independent eigenvector, it means that the determinant is not equal to 0. That's the meaning of linearly independent eigenvector. We only have one linearly independent eigenvector in this question. So since we cannot have another one, Then all we need to do is to find a generalized vector u2 by solving this system. Okay, this is my A. R is minus 3, so that would be 6 minus 18, 2 minus 6. Then here u1 u2 equal to, we have the u1 already. We have this eigenvector, which is what? Which is 3, 1. The augmented matrix will be combinations of this one, and that will be 6 minus 18, 2 minus 6 with a slash, a line, 3 and 1. So that's the augmented matrix. Okay. So we have row 2 is equal to 3 row 2 minus row 1, and that will be equal to 6 minus 18. Okay, so this will be 0 times 3, then minus 6, and this will be minus 6 times 3, that's the minus 18, then minus 18. So this one is also 0, and this will be what? Times 3 is also 0. Okay. So we now have 6 u1 minus 18 u2 equal to 3. So we have 6 u1 equal to 3 plus 18 u2. u1 is equal to half plus 3 u2 over 3 over 6 over 6. So we can write this as 3 u2 plus half. So what we are going to do now, let's consider u2 to be x. Okay, so we now have u1 equal to 3x plus half. Okay, therefore the second eigenvector will be equal to u1 is what? u1 is 3x plus half. Then u2 is x. Yeah, take x to be 1. Take your x to be 1. If you do that, then you have 3 plus 1 over 2. Okay, and that will be 7 over 2. So the second eigenvector will be 7 over 2, and then 1. Okay, so therefore this one, 7 over 2, 1, is the generalized eigenvector. So we now have the solution. The solution is the first one, which we have here as this one, exponential to minus 3t. Then the second solution as a function of t will become u1, don't forget that formula, that's u1t plus u2, and then exponential rt. So let's do that. Our u1, the eigenvector, the first one, that's a 3, 1. That's a 3, 1 times t. Then plus u2, which is the one we just got here, is our u2. That's 7 over 2, 1, and exponential r is what? Minus 3t. Then it affects. So general solution. The general solution is this equal to c1, this one, then plus c2. So that's the general solution. Okay, if you're new on this channel, there's an icon of the video. Smash, click on it and subscribe to keep track of the updates of this channel. Also, please click on like button and send your comments. Finally, please share this video on social media platform. Thank you for doing that. Okay, the next question we want to look into now, that will be the third case. Okay, so please join the next question for case 3. Okay, I'm going to explain in detail what happened